Welcome, everybody. Welcome to Positive Technologies. Welcome, Poznań. Welcome, everybody who's joining remotely. I'm also joining remotely today. I'm joining from Dublin. And today I will tell you about 10 things that we've learned from running production infrastructure at Google. So, right. So the topic is as I described. So let's start with introducing myself. So who I am and who are we in the topic, right? So I'm a site reliability engineer at Google for more than 7 years now. I'm based in Google's Dublin office, and I'm mostly working on cloud automation, archival storage, and online storage. I'm currently working on Colossus file system that you may have heard of from some papers published by Google. So my title is Site Reliability Engineer, and this is closely related to general DevOps category. You could say that there is a large overlap between what SRE, so Site Reliability Engineering, is and DevOps is. But what does Site Reliability Engineering actually mean? To learn about this, let's take a look at the words of the founder of SRE at Google, who actually invented SRE. That's Benjamin Traynor Sloss, who launched SRE 20 years ago at Google. He was tasked with a very challenging thing to run Google's operations in a way that software engineers would do. So, software engineers usually just develop software, and they are mostly concerned with making sure that the software is right? But if you want to run the software on a large scale, I usually have to have some operations team that deploys the software on a number of servers, on a number of machines, and keeps it running and stable and takes care of all necessary migrations. So the problem with the traditional ops approach is that it doesn't scale well, and it focuses mainly on operations. And if you employ software engineers to do this job, then you have this mix of approaches. Like on one hand, you have people that care about software velocity, and on the other hand, they also have to care about stability. So the essence of site reliability engineering is to balance the velocity and reliability. So, in his words, SRE is what happens when you ask a software engineer to design and run operations. So you could say that many people involved in the DevOps approach would fit into this category. Right. So this job title, this philosophy, SRE, it's called Site Reliability Engineering because back in the day, 20 years ago, Google was mostly a single site. That's why there is the site in the name. Of course, Google was already developing and deploying its other products, but it was mostly known for its search engine. So over the years, this has changed a lot. So as probably everybody knows, Google has a lot of different services and products. And the way how SRE works at Google is that it's engaged in many different places in the company. However, it's a centralized, it's a central organization. So it's not that every different service or product has its own separate SREs. I mean, there are different SRE teams, but ultimately they are not a part of the developer team. They are a part of the broader SRE family. So within Google, SREs usually specialize in certain areas. Like for example, I work in storage. Some other people may work more on the network side, or uh, optimizing computations and so on. But ultimately, we all belong to one organization, and that allows transfers between different SRE teams relatively easily. And this also, apart from the transfers themselves, it also allows to spread the culture of SRE between different teams. So we have a pretty homogeneous culture of work between different SRE teams. And the culture aspect of SRE is important. If you follow the words of Peter Drucker, culture eats strategy for breakfast. So uh, no matter how much strategy you apply to your operations to DevOps, right? It doesn't really matter if you don't have a strong culture in your company, if you don't have people following the same principles that agree what to do when there is a problem. So SRE is very um, SRE at Google. We take a lot of care to maintain our strong SRE culture. And yeah, today's slides will be about the 10 lessons that we've learned over the years, but they are strongly connected to the SRE culture that has developed. And I hope that these lessons could be applicable on many different scales. Google is a large company, but there are many small and mid-sized companies that I believe that they could also benefit from these lessons. So it doesn't matter if you have like hundreds of SREs in your company, or maybe just one, or maybe you don't have a dedicated SRE or DevOps person. Maybe this reliability role is done as a part-time job by somebody. Ultimately, I believe that the lessons that I'm going to talk about today, they could be implemented in many different ways. So yeah, let's get to it, and I hope you'll enjoy these lessons. So lesson number one is that reliability cannot be taken for granted. So yeah, it's easy to forget about this principle while there's plenty of reliability, right? So if everything goes well, then we don't have to focus too much on reliability. But when things are really going south, right, if they are going wrong, it's often too late to start fixing them. So the main principle here is that there always needs to be a voice for reliability, even if things seem to be reliable enough. And this means many different things. It means like that there should be always somebody advocating for reliability. It could be the developers of the service of the product. It could be somebody other than the developers. It really depends on how your company is structured. Um, Right, and it also depends on. I mean, this principle should apply in every stage of product development. So it includes like when there is like an early phase of the development, when the product is already available to the customers, and when it's being turned down. So this is related to one of the tenets of DevOps philosophy called shift left. So the planning for reliability needs to start early. Ideally, there should be somebody planning for taking reliability into account from the very beginning of the development of the product. So let's suppose this didn't happen, right? So let's suppose that the developer team creates a product that and they didn't care much about current or future reliability. And what this can lead to is a situation where we have a product that is really hard to maintain, really hard to keep running, really hard to scale. And this is a recipe for disaster, right? So it's really important to take this into account early if you don't want to completely start from scratch or abandon your current project. This is also very much connected with the Google SRE motto that hope is not a strategy. Right, and let's get to lesson number 2. Cattle versus pets. So this is a metaphor frequently used to address, to compare two different ways how server machines are handled by different people, different teams. Well, you could treat your machines similarly to pets. So they could have like unique names, they could have like different configuration. I mean, of course, like real life pets don't have configuration, right? But they have like different personalities. They are expensive to maintain. Like probably everybody that has a pet knows how much effort it takes to take a good care of a pet, right? Um, so this is similarly with machines. If every machine is slightly different, if you have to remember what's the difference between one machine or another, it's going to be just expensive to maintain all of this, and it will rely strongly on humans who remember what needs to be done where. On the other hand, if you treat your machines like cattle, like if you just assign them numbers and not names, if you keep them uniform, if they have the similar or the same hardware specification or software specification, then you can manage a much larger fleet of machines this way. And this approach is not only about machines. This can also be applied to software in general. So if you have a number of different products, and each product, each application, each binary, each project, if it's developed differently, then you have to maintain a variety of different setups, right? But if you decide on one technology or a very small number of technologies that you're using, if you decide on a specific way to deploy things in production, then you'll have a much easier time managing all of this. And it's not always about just money, right? I mean, you could just throw more money at the problem and solve it. But ultimately, if you're one of the main questions is what will happen if your company scales a lot? Like it happens to some companies, right? That they reach a point where they have to scale very quickly and dramatically. And like if this happens to your company, you should be ready for it, right? So if for example, this happens to your company and you have like a variety of different machines and different software running on it, then it could be that just the cognitive load that becomes a bottleneck. It's like you could throw more money at problems, but then what? Would you hire like more ops people to do the same work? Like they wouldn't have the same context as the people that were already hired, right? So uniformity here is the key to success if you want to scale up your services. Okay, let's take a look at lesson number 3, which is more about humans. It's about blamelessness, right? So, well, sometimes things go wrong, and it's tempting to blame somebody for these things, right? But the principle here that I would like to talk about is that you should assume that everyone in your company is competent and well-intentioned. Well, you could disagree with this or find some examples of some companies where you shouldn't do that, right? But uh, let's say for a moment that we shouldn't follow this principle, right? If you would say that we shouldn't we should assume that people are incompetent and that they don't have good intentions, then such a setup creates a situation where people tend to hide some problems or distort the reality, right? And this is not a good situation if you care about the state of production in general, uh, right? It's if you're going to let's say if there is some problem with production or outage, you should better have as much information as possible, and you don't want people to hide bits and pieces of information and fear that somebody will retaliate for making some mistakes. This is also uh, connected to the fact that uh, well, people generally make mistakes, right? Nobody's perfect, so it's not that if there's if somebody makes a mistake, it's not that it's unlikely that they are incompetent. It's just that probably they had a bad day or something, or just didn't consider all the possibilities. And this is natural. Like people keep making mistakes, and they will make more mistakes. So instead of fixing particular people that have made mistakes in the past, focus on fixing the systems and processes. Because if you have processes that allow these mistakes to be very visible, then maybe the process is wrong. Maybe you should, for example, involve more people in the process. Like for example, let's say if you have a developer team and they don't do code review, maybe they should start doing the code review and thoroughly, not just for the purpose of doing code review, right? So the purpose is to involve more people, like look at have more people to look at the code, so that there is a much lower chance that the code is wrong, right? And similarly with managing production, right? If a system relies too strongly on a single person, then it will be likely to break. So yeah, I already mentioned that uh, it's important to provide this psychological safety for the people, and for the reason that companies generally need information about what's going on, right? And only when we have the complete information will we be able to improve, and that concerns both like investigating current issues with production and fixing them for the later. uh, there's interesting point here. When problems are swept under the rug, they accumulate. Okay, so let's say that you don't follow the principle, the one that I told about initially. That if you assume that people are incompetent and they don't have good intentions, they will hide away some problems, and some problems could be small problems. But if they hide away enough of these small problems, they could accumulate and grow into a big problem. So it's better to deal with small problems when they occur than to deal with a large outage that happens as an aftermath of hiding too many problems. Right. So let's get to the next lesson. Measure what matters. So, well, this is not a lesson about measuring things. I know that measuring things, observability, and so on, it's very popular these days. But this, I mean, there is no argument about this. But this slide is about measuring what really matters. So, if you are measuring something but it doesn't matter, then maybe you shouldn't measure that. If you have some important metrics that you don't measure, well, then that's also a bad situation. So ideally, you should focus your efforts on making sure that you measure what really matters. And what really matters depends. It's a matter of agreement between the service providers and the users of the service. So ideally, if you have a service that is being used by some users, some customers, you should listen to them, what they want, what they demand, what level of availability, what level of data integrity they want. It really depends on your service, right? But Only when you talk with your customers about these goals, then you will be able to know what level of service needs to be provided. And of course, making a service very reliable, it can be very expensive. So maybe you don't want to make it too reliable. It's all about balancing, really. Uh, it's all about balancing the cost versus um, expenses uh, and risk management. So what SRE propose is to agree on measurable goals, so-called SLOs, service level objectives, to prevent conflicts. Uh, okay, what else do we have here? Anything that you don't measure gets worse. I guess this is just a fact, right? That every part of a software system gets worse over time if nobody keeps attention to it. Okay. Another point is advice: don't block. People find ways around the gatekeeper. Right. So that's about that's a word of caution. Uh, Generally, SREs and people alike shouldn't be too strict about these rules. Like if you impose rules that are too strict, if you, for example, agree on some goals that are cannot be delivered, then people that are meant to satisfy those goals, they will find ways around this problem, right? If they have to deliver too much, they will find a way so that the metric that you asked for, it is the numbers check out, right? But actually, there is some still there's still some problems. So you have to be careful about not making these things too strict. All right. So the next few lessons will be about operations. So a word on operations, which are an essential part of being an SRE. However, they are not the central part. So let's take a look again at the words of Benjamin Trainor's laws to see how we should treat operations. Right. So SRE is supposed to design and run operations. So SREs are supposed to do both these things. They shouldn't 100% spend their time on designing operations. They shouldn't spend all their time running operations. It should be a balance of the two. This is because the best way to learn how a system works is watching its failure modes, right? So if you are an SRE that's designing uh, various systems and various procedures, and if you don't follow them, if you are not a user of these procedures, then you don't know how they are actually working. You don't feel the pain of managing the production. So, like being involved in ticket work, in handling some automated alerts, in investigating what's going on in production, being on call for a service, it's very important. But it's also not a purpose of being an SRE, right? So that's what distinguishes SRE from the traditional ops approach. That on call is not a purpose; it's a means to an end. It's a means to learn about the system and fix the current issues and uh, improve the system in the long term. So with complex software systems, failures are also complex. They are easy to misinterpret from a distance. So if you work closely with problems, then you can see the tiny details, and maybe you can discover some pattern that will help fixing the issues long term, instead of just assuming that the issue that you're dealing with is just a known issue, and sometimes you just discover that some issues are different. They are not what they seem to be, and they require a different kind of fixing than it seems initially. Another point here, seemingly unrelated failures may have a deeper connection. So this is another reason to stay in the loop with operations. So if you're an SRE and you investigate and debug enough of production issues, you may start seeing some patterns that are not visible in a single production issue. Like if you are dealing with tens or hundreds of these issues, then you can start to connect the dots and maybe come up with some ideas for like broader reliability projects that may be necessary in many areas of production. So let's say, for example, if you have many services that don't have staged rollouts, that they don't have canary rollouts to production, you may like discover this, that many of them don't have this, and then you may come up with an idea to implement canary rollouts. Also, another reason to be on call and in the loop is that you need skin in the game to build up credibility. So let's say if you have a separate developer team and SRE team, if these SREs are not on call for the service, they are not like it's really hard. It's really hard for the developers to trust these SREs that they know what they are doing. Okay, lesson number 6. No heroes. So it's not about that heroes are bad. I mean, SREs are the heroes of production, but the heroism is just bad. So this is about like spending too much effort fixing the production on your own. If you keep being a hero, then it's likely that you'll burn out. Oh, no pun intended, actually. So heroism is bad for the hero, for the team, and the system. Yeah, this is because many reasons, right? One is that particular people will eventually burn out. The other reason is that if one person is a hero and gets like better results, then other people will also maybe they will also want to be the heroes, but ultimately it leads to burnout of the entire team, and it just creates the situation where people work too many hours and everybody is unhappy. Also, reliability shouldn't depend on somebody working after hours. So well, if there's a production problem that needs working longer hours, maybe instead of having one person investigate it, maybe the load should be spread across multiple people. Maybe you should put in more people to take a look. Maybe you'll get better ideas this way. So yeah, in this regard, heroism is bad. There's also another thing about heroism. So far I described heroism on a personal level, but it could be that entire teams could be heroes. So, for example, if there is a team that has too much load, like they are handling too many tickets, interrupts, automated alerts, whatever really. If they're just too busy doing the ops work and they never have time to work on automation or fixing the underlying issues, then it will lead to the burnout of the entire team. And sometimes it's better to say that, I mean, generally it's better to care more about the team of like highly skilled people than the service level agreement that you have come up with. So maybe the service level agreement, so the agreement between customers and the service providers, needs to be adjusted because the service is just inherently unreliable. And the only way to get extra time, money, resources to fix the service is to admit that the service is just not that reliable. Another important thing is that the on-caller's job is to make sure that the problem is fixed and not to fix the problem. So if somebody is on call in SRE and they are dealing with a problem, it's not that they have to fix the problem. If they, for example, find a person who's a subject matter expert, and they loop in the person into the investigation or delegate the investigation completely to them, that also counts. Like if you can find a more efficient way of dealing with the problem, you should definitely do that. And at SRE, in SRE at Google, we always say that the on-caller is never alone. And hopefully this is true in many other companies, that if somebody is on call for something, they can always reach out to other people on call from other teams, or people who are not currently on call. Like, of course, it's more problematic over the weekend to find some support, but generally it's better to escalate to people who are not on call than to just wait and for the production to degrade. Like if you have a one-off situation that you escalate to people who are not on call, I would say it's better to reach out to them, even if it's after hours, than allow this thing to possibly like destroy your company, right? If you have such a strong dependency on production, it could destroy your company, or like be very impactful on revenue. So, and this is also a lesson to be learned, that maybe you need more people on call or responsible for production. Right. Lesson number 7. Automate yourself out of your current job. So don't send a human to do a robot's job. Of course, everybody knows that there is a trade-off between doing things manually and automating them, and automating things takes time. But ultimately, things should be as automated as possible, especially when they are very similar. Like, for example, if you have to update some configuration file many times, maybe it's like many times in a month, then it's like many times in a week, then it becomes many times in a day, like if the system scales. And this is just becoming unreliable when the system scales. So you should use your best judgment when's the right time to automate any manual operations. Yeah, because it scales better than manual work. You really don't want to be in a situation where you realize that maybe I should have automated these things like a month ago, but now I don't have time because I have to keep manually updating the files. Like I suppose it happened to many of us in the broad area of SRE and DevOps. The lesson here is that maybe you should actually automate the things before they become a problem. Like if you can anticipate that something will become a scaling problem, maybe do this like a couple of months ahead of time, if you have such perception, of course. And it's not only about time and money, right? It's sometimes it's about consistency. Humans make mistakes, make typos. Sometimes these typos can be costly. So maybe it's better to have robots doing these things. And if you automate manual things, if you automate your manual tasks or your team's manual tasks, then everybody will have more time to do more interesting things, like, for example, programming, right? So this keeps people more interested in the job, and generally leads to a better long-term retention in the company, I would say. Generally automating things is a good change. And change is a topic of the remaining lessons. So we could say that change is constant, and it's true. It's true for many aspects. It's true for what we are doing in our jobs. It's true for state of production of many companies, right? And particularly, let's take a look at the change as a number one reason for outages. So you could say that the ideal state of production is when nothing changes, because this way we can avoid most of the outages. But this is not really an affordable thing, right? This is untenable. It's like companies have to change things because otherwise they would quickly go out of business. So this goes back to the essence of SRE. SRE is not about like making sure that reliability is uh, uh, as high as possible, right? It's about striking the right balance between reliability and velocity. Um, so as an SRE, you should find places like low hanging fruit that you can do to improve overall reliability and, for example, minimize unnecessary risk from changes. Again, getting back to the example where that I described before, where let's say we have multiple services that roll out globally without any canarying, without any A/B testing. Uh, this is a bad this is a bad state of production, right? It's like very risky. So as an SRE, maybe you could introduce like a company-wide or team-wide policy to roll out things slowly. Of course, it could take months, it could take years to implement, but ultimately it will be worth it. Uh, Another principle is don't only test in production. Well, I would even say don't test in production. Uh, yeah, it's just an anti-pattern. Use GitOps. So GitOps is this currently very popular thing. So roughly, it's about like keeping some, keeping your like the state of production really in some repository. Like keep your configuration files in a repository. Make sure that it's reviewed, like that nobody introduces any surprising changes that don't have any comments. This way you can easily trace back. I mean, it's much easier to trace back, like if there are any production issues that were that have a root cause in a misconfiguration. It's much easier to detect what went wrong where, right? If you have a chain of commits, you can see when they were committed, maybe when they were applied to production. Uh, it's just much easier this way to reason about production. Don't deploy on Fridays for varying values of Friday. Yeah, some countries have Fridays on Thursdays or on some other days. You should be aware of that, especially if you're working across multiple countries. Production freezes don't solve the underlying problem with changes, right? So it's tempting to sometimes freeze the production, freeze any rollouts for a longer time. Like let's say if you have like a daily or a weekly rollout cadence, you could say maybe I should slow down and release things like once a month. Uh, but that's well not generally a great idea, because every time a change happens, there is more and more individual code changes that are applied at once. So actually every such production change becomes riskier. Okay, lesson number 9. Outages are inevitable. So of course it all depends on the scale, but like outages will happen eventually. Like, there is no way to like be 100% safe from outages. And your products, as I argued previously, they need changes, right? And every change introduces some risks. So the goal of SRE is not to prevent outages entirely, but to limit their overall cost. And the main way to do this is like when an outage happens, don't try to root cause it. Try to mitigate it first. Try to uh, make try to stop the bleeding, right? Uh, because it's really like the life shows that it's really unlikely you will be able to properly root cause things very quickly. So of course you can stop the bleeding if you are prepared for this, if you have mechanisms to prepare the bleeding. So for example, uh, if you um, if you have a way to quickly roll back configuration changes, that's great. That can probably help mitigating the issues quickly. Uh, Of course, it depends. If you have some state involved, it may not be as easy, but for stateless things, rolling back usually works. Use written communication for incident management. So this is important when you want to delegate some duties between different people involved in handling an incident. It's best to have something like some online documents that everybody can write, like what happened at which hour, the decisions that were made. It really helps organizing stuff, especially if you're not all in the same office. And organizational transparency helps with root causing. Read code, not docs, right? So this is about, like, if you have multiple teams with multiple different repositories, it's important that other people have access to your repository, because it's much easier for them to root cause any issues. Like if there is some production incident that affects multiple teams, it's much easier if they can actually look at your code, look at your code history. It's much easier to handle incidents then. Okay. And the last lesson is that you should have no haunted graveyards. So, haunted graveyard is a system that becomes so fragile and complex that no one dares to touch it. And of course, nobody designs haunted graveyards. They just happen to, they just occur naturally. And how do they happen? It all starts with broken windows. So some things that uh, uh, are slightly broken in the system, but people generally tend to ignore that they are broken, or say, okay, this is a small issue, I'll fix it later. But if you accumulate enough broken windows, eventually your house becomes a haunted graveyard, and the system becomes so complex that, yeah, nobody wants to touch it, fix it, sometimes even replace it. So the key point here is that anybody can build complex systems, and instead of building complex systems, it's easy, right? Try building simple systems first that satisfy the same properties. It's much harder, but if you're building something really critical for your company, it will pay off later. So we've been through 10 lessons, and what did we actually learn? There are several themes here. So common themes are relationships. It's like really a lot of what's going on in SRE. It's all about the culture and between the people. And even though SREs are not the parts of they are not part of the developer team. Uh, in Google, we all feel like a single team working together towards a common goal, which is like making products great, services great, and making sure that they work for the users. What else? We know that change is constant, right? You can't keep doing what you're doing. This is true for both what humans are doing, and the state of production also always changes. And if production doesn't improve, it stagnates, and it can get worse over time, and may reach a tipping point after which fixing it's not that easy, right? Engineering is important. Discipline and hard work will only get you so far. You have to apply engineering principles to production if you want to make sure it's going to be sustainable. Like feeding it with human sweat or blood, it's like not a long-term solution. And simplicity, boring is better. Don't outsmart yourself. Your future self is going to regret it. And that sums up my presentation. So thank you for listening, and I hope you enjoyed it. And yeah, maybe I still have 1 minute to answer some questions. I don't see any questions. I don't hear any questions, but well, if you want to chat more about SRE or reliability, you can always find me after this presentation. Thank you very much. And I believe the next presentation will be from Jarosław from Red Hat.